Welcome to The Explainer. Today, we're going from the factory floor to the crime scene. Our mission? To solve the mystery of why these massive industrial furnaces just stop. And more importantly, how you can crack the case before it costs a fortune.
All right, here's our game plan. First, we'll look at the million-dollar problem. Then we'll get into the science of the melt, meet the usual suspects, the ghosts in the machine, and then I'll show you how to play furnace detective. Finally, we'll see why prevention is where the real money is.
Okay, let's head to the scene of the crime. A silent furnace. It doesn't look like much, right? But for a business, that silence is the sound of money just hemorrhaging.
And that right there is the heart of the matter. We are not talking about a minor inconvenience here. This is a full-blown financial crisis waiting to happen. I mean, thousands of dollars an hour. Poof, gone. Every minute that furnace is down, you're just bleeding cash.
You know, these furnace trips, they're the real villains here. They just stop production dead in its tracks with zero warning. It's like a ghost in the machine. So the question is, what's really going on? What's causing these sudden, super costly shutdowns?
All right, to crack this case, we've got to understand our victim, the furnace. So let's get into the science of the melt and figure out how this thing actually works. So how do you melt tons of steel without a single flame? The answer is magic. Well, science that feels like magic. It's this amazing thing called an eddy current, discovered way back in the 1800s. Think of it like creating these tiny, super powerful electrical whirlpools right inside the metal itself.
And this diagram really helps visualize what's going on. You've got this changing magnetic field, right? That field basically stirs up these currents inside the metal. The metal fights back. That's resistance. And that fight generates an incredible amount of heat. It's an amazing way to melt stuff without ever touching it.
Okay, so let's meet the key players in this whole operation. First up, the refractory lining. That's the super tough ceramic bowl holding all that molten metal. Then you've got the helical coil, the copper tubing that's the muscle, creating that magnetic field. The power supply is the heart of the whole thing, pumping in that high-frequency current. And you absolutely cannot forget the cooling system. It's the lifeline, stopping the whole thing from, melting itself. It's a real high-power, high-stakes dance.
Okay, we've got the science down. Now the investigation begins. It's time to round up the usual suspects. Let's meet the ghosts in the machine that cause all the trouble.
Overcurrent. That's a sudden jolt of electricity, like a total panic attack for the system. Then there's temperature runaway. This is when the cooling fails and the furnace basically turns into a giant ticking pressure cooker. Of course, you've got component degradation. Parts just get old and tired. Things like thyristors and capacitors, they just wear out. And my favorite, harmonic distortion. Think of these as invisible energy vampires, just sucking the life out of your power supply and causing chaos.
But here's the thing. A furnace almost never just dies without warning. It whispers. It gives you little clues that something's wrong. And this is where a good detective really shines. They know how to listen for those whispers.
So think of this chart as your detective's cheat sheet. It connects the symptoms to the likely cause. Hear a weird humming noise? Don't ignore it. That could be a loose connection that needs an immediate safety check. Noticing that the furnace isn't reaching full power anymore? Well, your capacitors might be on their way out. This isn't just data, it's an action plan. It tells you what to look for and, crucially, how fast you need to act.
All right, so we know the suspects, we can spot the clues. Now it's time to gear up. Let's talk about the tools and techniques you need to play furnace detective.
The key here is to not panic. You got to be systematic. It's like a pyramid. You start at the bottom with the basics, your own senses. What do you see, smell, hear? Any weird vibrations? Then you move up a level. You trace the power, step by step, from the wall to the furnace. Then, and only then, do you bring out the big guns, the specialized tools to stress test the really critical parts.
But, sometimes the easy clues aren't enough. For those really tough cases, the phantom problems that nobody can figure out, well, that's when you need to level up your toolkit.
And this is the specialist toolbox. We're talking thermal imaging to literally see heat and find hotspots before they fail. A power quality analyzer to catch those invisible energy vampires we talked about. An ultrasonic detector that can actually hear electrical arcing. And the granddaddy of them all, the oscilloscope, which is basically an EKG for your furnace's electronics. You can see its heartbeat.
Okay, let's see how this all works in the real world. Let's look at a case study, the phantom overcurrent trip.
The scene is Johnson Metalworks. They've got this one furnace that just keeps tripping, always with the same overcurrent alarm. And nobody, for the life of them, can figure out why.
So the investigation starts, and it's a classic case of just chasing ghosts. The techs are doing everything by the book, replacing all the usual suspects, thyristors, capacitors, sensors, you name it, they replaced it. But the problem just kept happening. They were spending a ton of money and getting nowhere because they were looking in the wrong place. And then the aha moment. They finally bring in a power quality analyzer, one of those specialist tools. And guess what? The problem wasn't in the furnace at all. The culprit was an outside job. Every time a different big machine in the factory started up, it sent a huge voltage spike down the line. The furnace was just protecting itself from these external attacks.
Case solved. Once they knew the real problem, the fix was actually pretty simple. They installed a special transformer to isolate the furnace, basically giving it a shield. The result? 18 months, not a single trip. It's a perfect example of why you have to look at the whole crime scene, the entire factory, not just the victim with the flashing light.
Okay, so being a great detective is cool and all. But you know what's even better? Preventing the crime from ever happening. That's where we move from being reactive to being proactive.
And this is your battle plan for prevention. It's a maintenance schedule that turns an unpredictable machine into a reliable asset. And notice the details. You're checking the critical water cooling system daily. You're checking power connections weekly. You're diving into the capacitors monthly. It's not just random checks. It's a smart, targeted strategy.
But really, it's bigger than just a schedule. The real goal is to create a culture of reliability. That means quick daily checks, yeah, but also deeper monthly investigations with the advanced tools. It means training your operators to be your eyes and ears on the ground, logging those early warning signs. You gotta remember, maintenance isn't a cost on a spreadsheet. It is an investment in your bottom line. It's an investment in uptime. So, I'll leave you with this question. The next time your furnace starts acting up, are you going to be just another technician chasing ghosts? Or are you going to be the detective that solves the puzzle? Because every failure tells a story. And if you learn how to read the clues, you can master the chaos and keep the heart of your operation beating strong.